Hi folks, Harry Frank for FX PhD, kicking off week 2. And this project that we're going to be doing this week is going to introduce position control and a lot of other things, but this is sort of when we dive into separating our different types of expressions. I mentioned last class we've got scalar values and array values, and array values get into controlling things that have more than one value, so x and y. And what we're going to do this is, or how we're going to do this is by making up a little interface. And again, this is one of those things that manually animated, this would be, and again, I don't want to use the word impossible, but near impossible. And if you can take the time to set things up with expressions, yeah, you can lose a little production time in the expressions programming side of it, but then how quickly things progress from there once it's all rigged up and ready to go are well, things move so much faster once you've got it rigged up. So let's say we needed to mock up some sort of user interface kind of thing, or this sort of screen flow kind of or whatever this is, sort of mimicking the Apple iTunes kind of interface look. This is probably going to be at least 2 classes going through all this stuff, because we also have heard from users that classes can get a little bit long and they start to be 50 or 60 minutes long, and we don't want it to be that long. So I'm going to try to keep this under 30 to 40 minutes. So that said, I'm going to stop my yapping and get into the concepts here. So first, let's visualize what we want to do. So right now, I'm using this little controller, so I'm using this thing down here to drive the animation. So there probably could be a number of ways of doing this. I guess I could set up a slider control or something like that using an expression controller, but I'm just going to use this little solid down here. So I'm going to have this position, the x position, drive the positions and rotation values of these images up here, and have all of them do all the proper offsets from each other and sort of transition in and out like that, just like so. And there's a number of things that are happening here that are under the hood that we'll go into. So this is a lot to cover, so let's get started and let's create our ScreenFlow UI here. Okay, so let's start in a new comp, and I've got just a little solid here that is 20 by 50 pixels. And let's start with a bunch of theory first, and this might actually carry us quite a bit through the first class, just covering how to handle things like position and scale and Z position when we use expressions. So let's just start with this little guy here. In fact, maybe I'll bump this up so you're not squinting at this little thing. Let's maybe take this to 50 by 100. And let's look at position. So if I create an expression for position, the first thing you're going to notice that if you're new to expressions, if you put a number in here, that you're going to get an error. Now, a lot of people, their first instinct is to say, I got an error, and hit OK, and not actually read it. But if you take a look here, it's actually telling you exactly what the problem is. The expression result must be of dimension 2, not 1. So what we're telling this is that we want 5. But in here, position is 2 values, 2 dimensions, x and y. If we're 3, this would be 3. Must be a result of dimension 3, not 1. I've seen this so many times in forums of people saying, this is the error I got, I have no idea what it means. Well, read it, tell you exactly what's going on. You're not giving it the right amount of data. One number doesn't account for all 3 values. So how do we account for all 3 values? Well, if I put 3 values in here, like 5, 100, and 5, it's still not going to actually work, although we're getting a little further. Actually, curious, yeah, okay. I was just curious if I added a semicolon, if somehow this would work. But there's a certain formatting that we need to do. This is a very standardized thing with JavaScript. And when we talk about arrays or things that have multiple dimensions, we need to use brackets. So this is just to the right of the P button on your keyboard. that bracket right there starts our array, and the other bracket, the right bracket, ends it. So we need to put our values inside here, and we need to separate them by commas. So let's say we do 0, 1, 2, right bracket. Here we go. Now we've plugged values directly into our square. Now notice it's up here. Now it's using the anchor point to position that. So if we wanted this to actually be totally inside the screen, we'd have to adjust the anchor point so that it is right up there at the top. Let's undo that. So connecting this to some other points that we had last week, we started to use things like time. So if we wanted to integrate time into this, we could do this a number of ways. I could just plug time directly into X right here, and this would quite slowly move. Or I could say time times some larger value. Now it's going to move even more quickly. But once we start doing that, I think that's a little visually confusing, and we should start thinking about using variables. Oops. So I would do something like this: x equals time times, let's say 50. Don't forget your semicolon. Exclamation. I don't know where I came up with exclamation. I think I've been talking about that with my 4-year-old lately. And then down here for the x value in the x slot, that would be the x value. So we would plug in that time value up there. Pretty straightforward. Now let's say I wanted this to move and then stop at a certain point. There is no stopping here. This is just going to keep moving as long as the composition keeps moving, as long as time progresses, or as long as I somehow change this value. So we're going to get into something that is very handy, that allows us to map values over certain ranges. Sort of like range mapping, if you've ever done that in Cinema 4D. And this is called a linear function. And the best way to start wrapping your head around it is to use it with time, and then we'll expand from there. So I'm going to move this over time from one point to another. Now, one thing you're going to notice is if I grab this, I can't move this square, and that's because we have assigned fixed values to this. One way to alleviate this problem is to, at the very beginning, add its existing value. So whatever this value is before the expression, if I click on the disable expression, let's say, actually why don't I just reset the transform so it's right there at the center. So I've got its center position as its starting value, and then that value plus this stuff. In fact, why don't we just set this to 0 and 0, so we're not adding anything to y or z, we're just adding values to x. But I can still move this, so I can move it up here, move it up here. I can have this move faster by increasing this value. But I want it to stop, so we're going to get into another term here. So instead of using time times 100 and just having something that moves increasingly and never stops, we're going to use something called linear. And I think this is in, where is this in here? Is this under property? No, interpolation. Sorry. Here's your nice little reference here. So linear outputs a range of values. And when I first learned linear, I sort of got caught up in it always being connected to time. It doesn't have to be connected to time, but it's an easy way to start to understand it. But let me drop this in here. In fact, let me drop the default setting in here. Now this is going to give me an error because it's using variables that haven't been declared. This is just sort of a reference. So right here, some value, it's minimum value, maximum value, and then out value 1, value 2. What does that mean? Okay, usually when I type this out, I speak out loud. I always say what I'm actually doing here. So what linear does is look at a certain value that's changing right here. T is changing. So an easy way to get a changing value is just to use time. So linear is going to output values using time as a rate. And as time changes from one value to another value, this whole thing will output values between value 1 and value 2. Don't panic if that doesn't make sense. I'm going to do this a few times. So let me plug in some real numbers in here. Let's say 0 and 2. And then actually I'll leave that as value 1 and value 2 so you can just see those where they are. And I'll use value 1 and value 2 as variables here. So let's say value 0. Value 1 is 0. I'm sorry. Value 2 equals, let's say 1,000. Okay, let's take a look at what happens here. Where is my... Let's turn this off and reset my position. Okay, so what this is doing is we are assigning x equal to a series of values. These values change at the rate of time as time changes from 0 to 2. As time changes from 0 to 2, we will output values from this whole thing from value 1 to value 2. So it will do this at a linear rate. So as time changes from 0 to 2, we will output values and plug those into the value of x. And actually, I should have my semicolon here at the end. From value 1 to value 2. So I always say create a linear relationship at the rate of time as time changes from 0 to 2. Output values from value 1 to value 2. So this goes backwards and forwards. So I mean, time is always going to move forward, but if we use something else in here for time, if this moved, if this moved below 0, it would just be locked to 0. It's never going to go below 0. It's never going to go above 1,000 in this case. But what this is going to do is start here at its starting point. Now remember, we're adding the existing value. So this is its center point plus 0 at this point. So let me actually move it over to the side. So we should see this move from 0 to 2 seconds and move 1,000. Well, okay, it's starting at 6, but let's set the existing value to be 0. So it's going to move from 0 in the x to 1,000 in the x from 0 seconds to 2 seconds. So instead of doing this up here, I could just do this 0, 2, 0, 2, comma 0, 1,000. You can see why I use the variables at first, because otherwise you just see a big stack of numbers in here, and that gets a little confusing. In fact, why don't I put a comment in here so we can see the reference here. So this is linear t min, t max, value 1, value 2. At the rate of t, as t changes from the minimum value to the maximum value, output values that range from value 1 to value 2. Pretty cool. So this is an easy way to move or change values at a certain rate. So in the case of this final project here, we are certainly going to be mapping values as this item moves from this side to this side. So as this value in the x-axis is here, this value is its minimum and its maximum value is over here. Okay, so let's take this a little further and drop a picture in here. I don't like that picture. I don't know why I used that one. Here. Very generic stock photo picture. Let me scale this down. So we're going to get beyond the idea of using time as a linear relationship and have this position, which doesn't really need to be three-dimensional. I was just using that. So let's use this position from a point over here to a point over here and have that drive position from this this image from off-screen here to off-screen here. So, in fact, this position right now is not going to have any any expressions. Actually, all the expressions are going to go on this one right here. So let's look at the position of this. Create a expression, and I think at this point you probably have all the tools you need to make this happen. So if you want to challenge yourself, try to do this, pause, come back. All right, hey, did you figure it out? Or did you just sit there and wait for me to pause for 1 second? That's fine, you can do that too. So let me look at the position of this, and often, like, I don't have the whole expression visualized as I do this. Like, I don't have this, like, okay, I'm gonna go like that and type it all in. I usually start with the things that I know that I need. First thing I know that I need in here is I need to look at the position of this thing and probably assign it to something. So that's the first place I'm going to start. So let's say, actually I'm not going to use X because that'll be, we'll call this X slider. Equals, let's use the pick whip to pick whip that value down here, and semicolon. Now something interesting just happened here, and this kind of goes against what I've said before, that this shouldn't actually work, but it does. Sometimes when you assign variables and you don't account for one of the values of the array, it just assumes it to be 0, and that is often the case. And that's actually what's happening here, because we have assigned a variable. Well, it technically shouldn't be working, but actually it does work. Okay, so anyway. So what we need to do is map the value of this slider down here. Oops. There we go. Okay, let's disable this expression. The value of this slider down here as it moves from one spot over here to a spot over here. Now we need to figure out what these spots are going to be. Like, is it 300 to 1,000? That sounds good to me. Those are pretty generic locations. So let's say, okay, well let's use those as variables. So let's say slider start equals 300. Slider end is equal to 1,000. So these are the starting and ending points that we're going to map. Oh, now it's getting confused. It's saying dimension 2, not dimension 1. Okay, so as this slider here, this little handle, slides from 300 to 1,000, I want to move this image from way over here to way over here. And actually what we'll do is we'll just make it move from one edge of the screen to the other edge of the screen, because this is an interesting concept I want to cover. Okay, so we're going to get into our linear relationship. So we want to make a linear relationship between two sets of values: the slider end, beginning and end, and the image position beginning and end. So we're going to use a linear relationship of X slider as slider moves from, we'll just move these, slider start to slider end. Again, I could have used fixed values in here, but this makes things just visually easier to read and easier to change, I think. Slider start, slider end, and then we're going to output values. So what are those values going to be? I said we're going to go from this side over here to this side over here. So I'm going to move this from 0 to another value. Again, I could use variables for this, but I think we can just plug in existing values. Now, here's a cool thing we can do. I didn't even tell you what resolution I'm working in, but it doesn't really matter. I'm working at 1280. You could be working at 960 or 1920 or whatever. It doesn't really matter, because instead of saying 1,000 and then having that not quite be, oops, hey, let's say linear must be scalar. Yeah, linear is outputting one value. Well, we'll fix this. So instead of using a fixed value, I can tell it to just use the width of the comp. And the way we do this, in fact, this is in here, property, oh, not, I always forget where, let's see, comp, width, right there. Width is a reserved word. Now, if we use width on this layer, it's actually going to refer to the width of the current layer. If I just say width, okay, let's actually do that and then finish this up. So we need to, again, properly format this for an array. So we got two variables here. Linear is just outputting one value. It's a scale. It's outputting scalar values. So, or in this case, it's outputting scalar values. We're saying output numbers between 0 and the word width. So what I should do is assign this to a variable like x. So x equals this linear relationship, and then plug this into my existing values. So left bracket x, and then whatever I want my y value to be. I can just make this a fixed value for now, just to make things easier. X slider, I'm sorry, x. Okay, what I'm trying to do is plug in, sorry, okay, I should have read the stupid error message. It's saying argument 1 linear must be scalar, because everything else I've used in here is scalar, or actually this argument right here needs to be scalar. It needs to be a single value. What I'm telling it to do is use position, which is how many values right here? 2. It's saying I'm plugging too many values into this linear relationship. And what I wanted to do was actually look at just the x-axis. Right now I'm looking at x and y. So to do this brings up an interesting point. Right now, x slider is equal to 2 values, x and y. If I want to use just one of these values, I need to declare the spot inside the array that is just the x value or the y value. Now you can, you've probably seen this if you've pick whipped just one value. If I say just get the position x or position y, you'll see that we end up with this bracket and a 0. Anytime we're dealing with an array, and arrays can have numerous values in there. We could, this isn't, arrays are not limited to 2 or 3. Arrays can have 100 values in there, all separated by commas. All these slots, all these value positions are numbered, and they start with a number 0. So x is value number 0, y is value number 1. 0, 1. If this were 3, this would be 0, 1, and 2. So to get that value of slider, x slider, I need this to be not position, which is position xy. I need this to be position for left bracket 0, right bracket. This should work. Here we go. So now as I move this from when I hit 300, this will start moving. And it's moving to, how far is it moving? It's moving to 849 pixels. Let's look at the width of this image over here. 849 pixels. Look at that. So I don't want the width of that image. That's pretty arbitrary, especially considering that I have actually scaled it down 49%. So that number means absolutely nothing. More importantly, we want the comp width. So we type this comp, capital C, period, width. This will now be moving from 0 to the other side. Again, our anchor point is in the center, so it's going to move from the center, it's going to move the image based on that anchor point position. So the anchor point position starts at 0, and over here the anchor point position is at 1280. If I want it to move just beyond that, then I would probably want another variable in here. So I'll use like end position. I can't use position. Remember, position is a reserved word. So down here I'm going to use end position. So we want this to be the width of the comp plus the size of the image, which is 849, right? So it would be plus width, right? Not quite. And I probably spelled position wrong. And position, I do that. Position. I always position. Okay. It's actually shooting a little too far. because we've scaled it down. Oh, what do we do now? Okay, so instead of the whole width of it, I want it to be the width times the scale. So let's do width times, let's get its scale. And remember, we're outputting a scalar value here, so I'm not going to go down here to scale x and y. I'm going to assume that my scales are locked together, and I'm just going to grab one of them. So this is going to be width times the scale. In fact, we don't need the word transform, just clutters things up. Width times scale 0, and we're still not quite there because we are getting a value of 49. We don't need 49, we need 0.4, right? So instead of multiplying this by 49, it's way the heck out. It doesn't even chart. It's 36,000 pixels out in that direction. We don't want to multiply it times 49. So in parentheses, I'm going to divide, or have this be 1 divided by this. I'm sorry, not 1 divided by. Bad math there. Scale divided by 100. Hey, and that does it, right? No, it's still, as you can see, way over here. Now, what's going on with that? Well, again, remember that our anchor point is right in the center. And what we want it to do is move right there. So technically, this isn't the width of the whole thing. We want it to move 1/2 of the width all the way over there. So we could do this a number of ways, but I can just take width divided by 2, put that in parentheses, and that should do it right there. So it goes right to the edge of that comp. So half of the actual width of it, which is its width in pixels, but we've scaled it down. So as I scale this, it doesn't matter how I scale it, it's always going to account for that scale. So it's going to move it from one side to the other. So while we're at it, why don't we, as our last thing for this lesson, account for its starting position. So let's go, here goes start position. We can probably use a lot of that. Just kind of copy and paste this. And let's adapt. You can probably guess, well, okay, the starting position is 0, really. So we want 0, but then we want to subtract the width of it divided by 2 and all that, right? Right. So let's go in here, take this starting position. So instead of making this start at a fixed value of 0, let's make it a variable, that variable starting position, or start position, which is that 0 point minus half of the width. So there it goes, from there to there. Very cool. This is now independent of scale. So if I move that, or if I scale it up, or scale it down, it's going to move from one side of the comp to the other. Now this little thing here is actually free to roam on its own. If I want to lock this down, let's lock this position in y. So let's say the value here can be, let's see, its position. I'm trying to think of the best way to do this. Well, okay. So remember, everything goes in brackets, right? So something in brackets, this comma that. Remember, position x is what we want to change. So our first value can be position left bracket 0. So that's its existing position for the x value. So it's basically a changeable, modifiable x value for x. And then y, we can make a fixed value, which shouldn't be 100. Let's make it something like 800. Oh, not 800, because this is 720 high. 500. Okay, so now I can't change the y. I cannot change the y value up and down. I can only move it in the x-axis. So next week we'll start by clamping this so it can only move from one range to the other, but I think I've gotten just about far enough. We made some pretty good progress here. We covered a lot of good stuff. My lesson plan, I said I was going to cover things like wiggle and noise. Mostly I wanted to cover using linear and array values, which is what we did. But we'll definitely get into wiggle and noise and all that kind of stuff in later lessons. I just needed to flop things around here a little bit. So anyway, until next week, we'll see you on the forums, and next week we'll jump back or start right where we left off here. Thanks. We'll see you next week.